All right, it's time for probably what is or will be my favorite part of the course, SSH, remote access, secure shell, open SSH. There's lots of different programs that can provide remote access to the command line on your server. The most popular one, the one that's bundled with every Linux under the sun pretty much, is open SSH. Some companies pay a third party for a commercial SSH implementation, so you may, depending on where you work or how you're working with Linux, SSH, the version of SSH that's running in your servers may be different than the version of SSH that we're going to show here, which is OpenSSH. But by and large, I guarantee you there's going to be a lot of similarities. There's going to be a lot in common. So I would not worry too much about differences with that, although we are going to cover OpenSSH. The first thing to do is to make sure that OpenSSH is installed. So on Red Hat, we're going to do yum search SSH. And so we can see OpenSSH-server, yum install OpenSSH-server. It's already installed, that's great. Let's just check Debian. Gonna search OpenSSH. We got OpenSSH, a lot of things that mention OpenSSH. OpenSSH-server. It's not installed in Debian. We'll install it. Now it's installed. Now on OpenSUSE, it's a little different. SSH is installed by default, but it does not run by default. So you'll want to do sudo service sshd start. And then you can SSH localhost. I was going to say, the authenticity of localhost cannot be established. Are you sure you want to continue connecting? Yes. When you say yes, the fingerprint, the cryptographic fingerprint of this system is added to a local file where it doesn't know that we're SSHing from the local system to the local system. Usually with SSH, you're SSHing from the local system to a remote system. And so what it's doing is it's saving the cryptographic fingerprint of the remote system. And the cool thing about that is if you ever get this message that says the authenticity of host whatever can't be established, but it is a system that is there, then something evil is going on. In fact, a lot of the time, almost 99% of the time, if you SSH into a server that is not the system that you think it is, or the system has changed in some way, you will get a completely different warning. It'll say like, warning, 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 someone is trying to do something nasty. This fingerprint on the remote system doesn't match a known fingerprint for that system. Don't give it your password. So put in the password, and now we're in via SSH. And so this says :0, which is a local connection, and :1 is an IPv6 IP address that is the connection from localhost. It would show a network IP address if we were connected via network. Let's switch back to our Debian and Red Hat systems. So with our Red Hat system, we were able to SSH as root. It's like, there was one failed attempt since the last login. I SSH'd in as root. And what about SSH localhost? Now keep in mind I'm running these from a privileged command prompt. Now the Debian system, I'm unable to log in as root, but can I log in as W? I can specify that. It's like the letter W at, because I think that's what is that my username? No, my username is Wendell, I think. Username's Wendell, okay. So I can't SSH as root. Can I SSH as Wendell? Yes, I can, and now I'm in as Wendell. I can become root. By typing the root password and using su. Now notice that I tried to use sudo because we installed sudo earlier, but I didn't actually add Wendell to the sudoers group. And so it's like, we've received the usual lecture from the local system administrator. Respect the privacy of others, think before you type, and with great power comes great responsibility. I typed in the password for sudo, and it's like, Wendell's not in the sudoers file. This incident will be reported, and it has been added to the system log. So there you go. But I knew the root password, which is a different password than my password. So my user's password. So I can do su, password, and now I have a root prompt. And if I type W, and we can see here, this is also ::1, and this is showing that this is a pseudo terminal, a PTS, is what that means. As opposed to this is a local connection to the system, and this is a connection from localhost over TCP/IP. This would be more obvious from a network type connection. Now, in terms of SSH clients for Windows, the most popular SSH client for Windows is PuTTY. And PuTTY has a huge number of options, so you should go download PuTTY now and hit pause. Don't worry, I'll wait. It'll be totally fine. Once you've downloaded PuTTY, you'll get something like this. There won't be any settings or anything like that stored in here. We should be able to connect from our host machine, which in this case is a Windows host machine. Although I'm going to switch to my Fedora machine for the second part of this course, because I don't really like using this Windows machine, but I figured that most people taking this course probably are going to be on Windows and probably going to be using VirtualBox for their virtual machine, so it's probably all right. So in Red Hat, we're on Debian. We can do IP-4A, which is going to show us all the active IPv4 interfaces. This is the IP address of this particular machine, so I'm going to do 10.0.2.15, and I'm going to try to open that connection. It's probably not going to work. It might work. Now, it doesn't look like PuTTY is going to connect on this side. And if I look at this, it's like, okay, I can actually see that this connection, we've got 10.0.2.15. That is what the IP address was back here, 10.0.2.15. So in VirtualBox, we're going to have to configure it so that my host computer and all of these computers can talk to one another, because as long as they're the same IP address, it's not going to work. So in VirtualBox, what you do is you go to File, Preferences, and then you go to Network, and it's like NAT Networks. There's nothing here, so we'll just call that one NAT Network, and we'll just say OK. And then you have to go to Settings of each of your virtual machines and go to Network and say NAT Network. If you don't do that, they're isolated from one another so that they cannot talk to each other. By putting them all on the same network, they will all be able to talk to one another, and then we can do some more interesting things. Now, if you're on a different networking system, and like if you're using Hyper-V or, I don't know, VirtualBox or QEMU or something like that, they all have the same functionality. If I haven't told you enough that you can figure that out on your own, then I would suggest that you set everything to be a bridged adapter. And what that will do is it will bridge your network connection on your host computer with the virtual machines. So it'll be like as if the virtual machines are physical computers physically plugged into your local network. This NAT network, what we're doing is sort of creating a little software-defined network with all of the virtual machines attached to it just locally here. So it's way more sandboxed. When you do the bridged connection, these virtual machines are going to be loose on your local area network. With this NAT network, they can talk to each other, but the outside world can't initiate a connection inside this little sandbox unless you explicitly set up a port forward. It's a very important distinction. All right, so we've got our 3 virtual machines rebooted, and we're going to run the IPv4-A or IP-4A on the commands. We can see that our Debian machine is 10.0.2.5. You can see that our Red Hat machine is 10.0.2.15. We can see that our OpenSUSE machine is 10.0.2.4. So your IP addresses, your setup may be a little different. So with PuTTY on our Windows host, which is what we set out to do, we should be able to connect from our Windows host to each of our virtual machines, right? Well, no, OpenSUSE doesn't connect the host machine to those virtual machines. So what you got to do is you got to go back to Preferences, you got to go to Network, NAT Network, hit the little gear, go to Port Forwarding. I've already added a rule here, host IP 127.0.0.1. That is localhost, that is home. And so 127.0.0.1 is an IP address that always refers back to your local computer, the computer that you are on right now. And so I've got a computer, and I've got 3 virtual machines inside that computer. 127.0.0.1 in the context of each of those virtual machines refers to each virtual machine in itself, and 127.0.0.1 on the host refers to the host itself. So 127.0.0.1 host port 222. I just chose an arbitrary port that was not in use. It's not port 22. Port 22 is the SSH port by default. The guest IP is 10.0.2.5, which you should know is the Debian, that's right, good job, system. And so the guest port is 22. We would need to add rules for the other two systems if we want to have a PuTTY connection, an SSH connection, open to each of the other systems. So I'm just going to start with this one. I'm going to hit OK on this one, hit OK on this one. I'm going to go back to Debian. I'm going to go here. We're going to do hostname. We're going to do localhost 127.0.0.1 port 222 because that's what we specified for the host information. And then we'll do open. And then we get a pop-up from PuTTY. It's like the host server key is not cached in the registry. You have no guarantees that the server is the computer you think it is. The server's SSH key fingerprint is this. And so if you trust this host, then hit yes to add the key, PuTTY's cached connection. If not, carry on. So we'll say yes. This is basically PuTTY saying, you've never seen this machine before. Are you sure that it's okay? So yes, we'll say that it's okay. And then it's asking me for a login. And I've logged in. So if we go back to our virtual machine and we type W, remember, it's like, oh, we can see that there's a connection from 10.0.2.2, which is a connection from the local machine that we're running here. But if we do a new session, a new PuTTY session, and we do 10.0.2.4, we open that, we'll see that it will time out. It will eventually say, oh, I can't connect, or oh, there's no connection, or anything like that, because we didn't. We have the networking system in Oracle VirtualBox is such that it's not going to let me do that. And if you were in bridged mode, then this works completely differently than it works now. Like with bridged mode, you would just specify the IP address. You would not have to do this 127.0.0.1 thing. It would just work. So that says connection timed out. Connection timed out means that nothing interesting is going on. I'm going to take this opportunity to switch machines. We can kill two birds with one stone in our learning, basically. We go to File Preferences and we go to Network, go to the NAT network, and we change this, port forwarding. We're going to go to this. I'm going to change this. Remember, .4 was our other machine. 4 was what? Our OpenSUSE machine, I think. And so if we do that and we hit OK, we hit OK, let's say that maybe somebody's got control of your network. You got a mischievous network admin that's messing with you, maybe wants to steal your password or worse. You know, what's going on with that? And so if I do a duplicate connection here, it's not connecting. Let's try SSH localhost. Oh, connect refused because we restarted it. Yes. Sudo bash to get a command prompt. And then we want to do service start. Software caused connection to abort. Okay. Restart. We still can't connect with OpenSUSE. So if we run our iptables command, iptables-l, we can see, oh, there are a lot of iptables rules by default on OpenSUSE. And so by default, the software firewall on OpenSUSE is also not going to let our inbound connection. So we need a command. And skipping ahead a little bit, we'll do iptables-I input in all caps -p tcp -m tcp -d port 22 because destination port 22 SSH what we want -j jump to rule accept. When we add that, we will be accepting our iptables connection at least until we reboot, because these commands that we're running, they don't make changes after the reboot. So we'll want to actually do this properly if we were not doing this in a lab type situation. So now we should be able to restart or duplicate this session, and then it's like, whoa, I'm getting a pop-up. And this pop-up that you get from PuTTY that I'm showing you here in PuTTY is just like the one you would get from the command line if you were, like how we were doing SSH localhost or SSH user at remote system. It'd be the same kind of a thing. Warning, potential security breach. The server's host key does not match the one PuTTY has cached in the registry. This means that either the server administrator has changed the host key, the encryption key, or you're actually connecting to another computer pretending to be the server. The new fingerprint is this. If you were expecting this change and trust the new host key, then hit yes. So this is saying basically the computer that you're connecting to is not the computer that you think it is. It's not the computer that you've seen in the past. This is extremely important for system security. You must be cognizant of these kinds of things. And it's like, oh, the server's down, and it's like 2 o'clock on a Saturday morning, and it's like, oh crap, the server's down, I better remote in and figure it out. And you get a pop-up like this, it's already too late, it's over. The host key changed, which means the system that you're connecting to is not the system that you think it is, because, you know, surely the system that's down you've connected to before from the system that you're trying to connect to it, because you got paged at 2 or 3 in the morning. You're trying to figure this out. So this is a very, very important message. All versions of SSH, whether it's Open SSH or one of the commercial SSHs or whatever, will give you a warning like this when you are connecting to a system that you have connected to before, but that it has a different fingerprint, a different cryptographic fingerprint, meaning the host has different encryption keys. So you should definitely stop trying to connect or do anything with that system if this happens and it is not an unexpected, and it's an unexpected situation. It's happening now for us because we changed where the port maps to. Like just a second ago, that was mapped to our Debian system. Now it's mapped to our OpenSUSE system, which they have completely different cryptographic keys, and it makes sense why this is happening. So I'm just going to hit cancel on this, and I'm going to go to File Preferences. I'm going to go to Network, and I'm going to go to the properties of this thing and port forwarding, and I'm going to change that back to .5. And I'm going to hit a little plus here, 127.0.0.1, 2223, 10.0.2.4, 22. We've got a new rule now. I'm going to hit OK, OK, OK. Going to go back to PuTTY, new session. And we'll do 10.0.2.4. I'm sorry, 127.0.0.1, 223. We'll do open. And now, instead of warning, 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 oh my god, everything's on fire, we've got the server's keys not cached in the registry. And we can see that the fingerprint here is the same. So we'll say yes, and then it's like, okay, what's your login? What's your password? Ta-da, we're logged in with a password. And see, we have a lot of fun, and we recognize this as our OpenSUSE system. We can do the same exact procedure on our Red Hat system and have a PuTTY, a remote PuTTY window, remote SSH window, to our Red Hat system, just the same. And we have the full functionality here to do whatever it is that you might want to do from the command line. And we can type W here and see that, oh, you know, I'm logged in from this IP address. If I were out on the internet somewhere, then that's where I would be logged in from. Pretty cool, huh? SSH is a really handy, powerful, super amazing thing.